Let me know if you cannot see it. Okay, so there are a lot of ideas here and not necessarily well-organized ideas. So I'm hoping that in our discussion, you guys can help me kind of take stock of what all of this means and extract something useful from very different lines of thought, right? Yeah, so the three topics I want to cover are primarily open games, which is this new formalism that has been developed in the applied category universe of people, most notably this guy named Jules Hedges. And I'm going to try to describe my understanding of it. But it actually, there's a lot of detail, a lot of technical detail there that I'm going to try to avoid because it's not that interesting for us. But I can send out the text later. And if you're interested in delving further into the category theory behind it, it's available there. The second topic will be sheaves, which kind of I'm a little more familiar with because I wrote a text on that, sheaves and prices, a few years ago. And I want to try to connect the ideas from that text to the notion of open games. And then the third idea regards microeconomics, basically, like marginal rates of substitution, and this construction called the Edgeworth box. And I basically want to see if there is some intuition we can draw from that, and kind of also I want to be able to answer the question, or I want to investigate the question of how much of microeconomics we can salvage, right? Because traditionally, leftist critiques of economics have to do a lot with critiques of rational actors and what constitutes like preferences for the individual. And I think we can still salvage some of economic theory without the ideological baggage, right? So I think that's another interesting line of questioning we can do. So the topics here are basically separated into three main lines, right? It's going to be game theory, and then leading up to open games. And then we'll cover a little bit of this competitive equilibrium stuff. I think this is not going to have a lot because, I'm not super familiar with it either. But I think it's worth at least starting down this line. And then the third one is going to be the other major part, right? Talking about sheaves of prices, and that's probably the most speculative part of the thing. So, and at any point, let me know if we should go further into a particular topic. Okay, so first, a kind of a recap of game theory. So a game here is basically three things, right? It's a set of players, it's a set of strategy profiles, and it's a payoff function, which takes a given strategy profile and tells us your payoff for it. So I think the thing to clarify here in the profile, a strategy profile is an action for every player. So this thing here, I'll just draw a circle around it. This epsilon or some sigma character represents the set of all possible strategy profiles, but a single element of the strategy profile is actually a list of actions, one for every player. So let's say there's 5 players in your game. then a single strategy profile is going to have 5 elements in that list, right? Just make sure that makes sense, right? And so therefore the payoff function is going to take, for every element in a single strategy profile, a payoff. Okay, so it'll make more sense when we use a familiar example such as prisoner's dilemma. So I'm sure a lot of you guys have heard of this.
Is R here just like the real numbers or something, or any?
Yeah. So R can be the real numbers. That's kind of the. Sorry, say that again.
Maybe any coset or something.
Yeah, exactly. It has to have some kind of order relation on it, but it can be fairly loose. It doesn't have to be a totally ordered set. So R doesn't necessarily have to be the real numbers, but yeah, that's the traditionally the one that's the easiest to deal with because you can differentiate and stuff on it, right? So yeah, the example of the prisoner's dilemma is, I'm sure many of you guys already know this, but just to recap here, there's 2 players, 2 prisoners, right? They're kind of separated in different rooms, and they're given the choice. Either you can help the police by telling on the other prisoner, or you can I think it's the C and D are cooperate and defect, right? So defecting means, of course, telling on the other person, right? Saying that the other person committed the crime, and then cooperating means you cooperate with the other prisoner, so you don't say anything, right? And so you can see here that a single element of our strategy profile, a single strategy profile will be a choice in the first set and a choice in the second set, right? So a single strategy profile would be something like C, C, or it would be like D, C, right? One element here in the tuple for every player. And then our queue simply maps for every possible set of actions the payoff for each. And there's 2 ways you can normally write these games. You can do a normal form, which is this box, and it kind of tells you the payoffs for every possible combination. And then the other form is the extensive form, where you kind of see it as a tree, and every stage of the game is represented as like a level of this tree. And in this case, the dotted line means that player 1 and player 2 are interchangeable here. So it's kind of it's a simultaneous game, right? Because player 2 doesn't know anything about what player 1 is doing. And there's many different extensions to this formalism, but this is the most basic idea of a game. And let's see. I think I have a slide later on. Yeah, so we'll get to Nash equilibria here, but there's a notion of equilibrium states, which are basically strategies where if you were to deviate, you would lose some reward, right? As an individual player. So there's basically no incentive to deviate. And so a big part of game theory is to analyze these sets of strategies where it doesn't benefit anyone to deviate from that strategy. Okay, so here's some different types of games. It's a very broad field, right? You can do simultaneous games, so both players act at the same time. You could do sequential, where player 1 does a move and then player 2 sees that move and responds to it. You can have complete versus incomplete information, so you know everything about what's happening in the game, or you only get some slice of the game state at every turn. There's perfect versus imperfect information, which is slightly different from complete versus incomplete. There's it has to do actually with knowing where in the game you are, where in the game state you are. Symmetric versus asymmetric payoff. So is the reward for doing an action the same for both players, or like does player one have a different set of payoffs than player two? And then there's cooperative versus non-cooperative, and many others, right? So this is just a small set, just to show that with the proper extension, we can kind of model a lot of different kind of economic situations, situations where there's some preference structure or some payoff structure. Okay. And I think the most interesting thing about the Nash Equilibria here is actually that it doesn't really matter what, sorry, let's say that Nash Equilibria, they are kind of computed in a global way, because it doesn't matter what the individual sees necessarily. It actually matters what all possible actions are being taken by all other players. So I think there is some connection between what we've been talking about in terms of like scaling phenomena and these equilibrium points, and I think that's something we should probably consider. So yeah, the definition of Nash Equilibria is that it's for any strategy set of strategy profiles, you choose one, you choose a subset of strategies such that the actions of every player is the maximum of the payoff, right? So you maximize the payoff with your choice of action. So in this case, you can think about this Q is the payoff, right? And this X asterisk is what you would choose, given that you would range over all of Y, and you would allow the other players to choose a different Y. And then you do the same with Y as well. So in this case, this is for a two-player game. You would have X and a Y as your actions, right? In this case of, in the case of the prisoner's dilemma, it would be defecting would be the Nash Equilibria. And let's think about why. Because if I confess to the police, if I confess to the police and the other player confesses to the police, we don't maximize our return, right? Actually, maximizing our return is when we both stay quiet. But when we confess, the reason this is an equilibria is because knowing that the other player is going to confess, then the best thing I can do is confess. And knowing that the player is not going to confess, the other player, confessing is still the best thing for me to do. Confessing about the other player, right? It's actually called defecting. Right? Because in either case, I maximize my option here. So in the case one, when the other person does not defect, I get 3 points by defecting. And in the case where the other person defects, I get 1 point by defecting. But in both cases, that is better than, or it's dominant. It's a dominant decision over the top row, right? If I were to, then I only get 2 points instead of 3 here, and I get 0 points instead of 1. And likewise for the other player. Yeah. So in that sense, the Nash Equilibria has to do with my own incentive. And there is another concept in economics called Pareto Optimality, which is the best or most maximizing choice for all players involved. In that case, that would be if both players cooperated. So the interesting thing about the prisoner's dilemma is that the Pareto optimal strategy is not the same as the Nash Equilibria strategy, right? And we can kind of see this happen anytime there's in economics what's called the tragedy of the commons, or situations where whatever's the utility maximizing decision for myself does not correspond to what is best for everyone involved, right? Yeah, so this is an important idea. Like the deviation from Pareto optimal and Nash equilibrium, that's where all the interesting cases of game theory kind of lie, I think. Okay, so John Nash proved that if we allow for a probability distribution over pure strategies, basically, if I say like, if I allow the player to say like some percentage of the time I'm going to choose action A, and some percentage of the time I'm going to choose action B, and so on. That's what's called a mixed strategy. If we allow that to happen, then any game basically that's not infinite has at least one Nash equilibrium. Yeah. Okay, so this is kind of like the basics of game theory, and what Jules Hedges and others have been working on is this notion of an open game. So what the problem with game theory traditionally is that it's very static, right? The boundaries are fixed. And while you can model things like nature or the environment, you generally have to model them in a very static way, right? They have to be built into the game in terms of a player. So some games, they'll introduce a player called chance or a player called nature, and that player can make a move just like the other players, right? And so there's some limitations to that because it doesn't allow for composition completely. So the idea of open games is to treat games like composable elements, so that you can take two games, combine them together to form a larger game. And so that's the main idea of open games, is that you can treat a game as a morphism in a category, and by composing morphisms, you get bigger games. So every game is actually a morphism, which is an interesting idea, right? Because we normally think of them as objects, maybe, but it's actually under this paradigm, which applies not only to open games but also to like open systems in general, right? So it's a big cornerstone of applied category theory. But yeah, basically, if you treat these games as morphisms that take some object to another object, you can compose them indefinitely. So the big question is, okay, what happens to the Nash equilibrium of one game once it's composed with another one, right? And here we can recall the earlier presentation. This is the connection to the earlier presentation on generativity, because we saw there that in the work of Ellie Adam, that we can actually formalize, right, this situation. Right, it's one of our favorite equations now, right? We've been writing this all over the place, but
Yeah, though the symbol on the right is different, right?
Yes, yeah.
It's an addition and a composition.
Right. Yeah, different ways of composing. Don't need the circle actually, like this. Yeah, so this basic idea of how something fails to be linear, let's say, it fails to equal the left side to equal to the right side. We kind of have the same thing happening with Equilibria, right? So we can say that, let's say f is a function that computes the Nash equilibria given the game. So this formula can then be translated naturally into the Nash equilibrium of game A combined with game B is not the same as the Nash equilibrium of game A plus the Nash equilibrium of game B. Now the plus here on the right side has no clear meaning, like it's not formalized what that means to add them on the right, whereas on the left you can, right? So there's something that intuition is not fully formalized, but I think it's still applicable here because I mean, this is one of the explicit goals that the creators of open games have stated, right? That they want to be able to study the non-transitive aspect of equilibrium as you compose these things.
What are the observations? So it's not anymore like decisions like the players within a game does. It's something else?
Yeah, good question. So yeah, actually I think this this is, maybe I did not label this perfectly right. So what is the arrow indicates is that some information is going from A to B. Mm-hmm. So from the perspective of A, I think you're right that A would be outputting some action. And from the perspective of B, B is seeing the action of A as well as some other information. So for B, it counts as an observation. So then the idea of an action for one game from the perspective of one game is the observation of another game. And similarly, for game A, the actions of game B yield a certain payoff or context for game A, a set of payoffs, right? So that's the main challenge for thinking about open games is that your payoff function is not given to you in an a priori way. It has to come from the other game that you're connected to. Okay, so we'll because this diagram here is just something I came up with. It's like a very naive way of thinking about it. I think we can be more precise by following the actual formalism. But at first, I want to outline some other ideas that motivate this approach. Another idea would be like, instead of having a distinction between players and the game itself, let's treat players like games. That is to say, every player, the same way that a game might have some local state that it needs to keep track of, the same thing is happening for players, right? The players are kind of like a computational unit that is receiving some input and outputting some stuff, right? They're also morphisms. That way we can actually connect players together and players to games in a way that we don't have to distinguish between them, right? Of course, there is some difference between them in the formalism, but it's very different from let's say in a traditional game theory where, right, you have players which are nodes, like these are the players, and the game itself, right? This is a player, and this is another one, right? P2, right? And then the game itself is this whole tree, right? So there's some distinction here, but to make it fully compositional, we can actually start to treat players as their own game, and then because of that, we can actually build basically multiplayer games from smaller multiplayer games. The other idea is we can treat the environment as a game. So, like I said before, in other approaches to game theory, we treat the environment sometimes as like a player called chance or a player called nature or something like that, that kind of makes a move in the game. But actually there doesn't need to be a distinction between environment and game. It can just be, because of how the composition works, we can communicate with the environment the same way we communicate to some other game. The next idea is that the notion of environment is relative, right? So whatever a given game is connected to becomes the environment for that game. So you have this kind of idea of like, game B can be the environment of game A and vice versa. And then there can be changes in the environment. So the environment can have a state, and it can update that state as time goes on, which will yield different payoffs. So in the prisoner's dilemma, the payoff matrix is a static thing, right? It's given to you as kind of the rules of the game. But imagine an environment where, let's say, on a given day, you have a police officer that's more or less generous with you, right? And so the parameters of the game might change. The parameters of the payoff might change, right? This is still the same rules, but I might, this instead of being 2-2 might be like 4-4 or something like that. And of course, if you change the payoffs enough, you're going to change the equilibrium points of that game. And then the final idea here is that every game keeps track of what is the best response to every profile, every strategy profile. So here is an interesting idea because we can think of these games as being their own, they're both a player and a game because they are keeping track of what is the best response given what it knows. And remember that games don't need to know everything, right? You can have games of imperfect information or asymmetric games, or so not every game sees the same information as the other games. So you have this kind of perspectival idea happening with games. So as individual game kind of encapsulates its perspective on the world in terms of how it should respond to different strategies by the other players. Okay. So how do we formalize this? This one I won't go too far into because it goes further into the category theory aspect of it. But open games are built on top of this thing called a monoidal category. And that's just a category that has this extra operation called the tensor product. And given any two objects, you can tensor them together to form a new object. And then you can do the same to morphisms. So this kind of allows you to compose in parallel, right? Normal composition in a category is only for arrows, right? So that like this would be the composition, right? This is like sequential composition. But a tensoring is like when you take two arrows and now they're kind of treated as one unit here, and the same for their objects, right? So I'll go further into that in the next few slides. Yeah, and then these isomorphisms just allow us to have some closure on the associativity and closure, right? So you have this unit, the monoidal unit, where if you tensor that, if you tensor that with any other object on either side, you have a natural transformation from that to the original object. And the reason this is a natural transformation is because in order to get this operation, it's actually a functor on the category to itself, right? So we're actually inside of a functor when we're talking about these tensored objects. Okay, cool. Do you guys have any questions so far on?
No, so far so good for me.
Okay.
Is this a monoid like functional programming in which like everything are functions and you don't have like objects and functions, you only have functions, or?
Yeah, it's similar. I mean, yeah, the word monoid is thrown around a lot, and the basic idea of it comes from algebra, where monoids are just sets of things equipped with an operation such that any two things combined together yield something in the set, right? So if A and B are in the set, then A combined with B, whatever this combinational operation is, belongs to that set. So there's a closure, right? And there's also a unit. So this belongs to S and this belongs to S.
But like within the category, you cannot distinguish between an object and a function, or can you?
And
Yeah,
in a
the
monoidal
G-
category, I think there's just one object, and that's like the tensor product. And the actual like elements are the arrows and how they compose.
Yeah. So there's the monoid as the category. So in reality, or in one perspective, a monoid category is just a single object that has well, not infinite, but like not necessarily infinite, but a bunch of arrows to itself. They're all endomorphisms, right? Or I guess automorphisms. But when you look inside the single object, you can unwrap some of this stuff and see this stuff happening, right? Yeah, but you're basically right. Like if in a programming language, if everything's a function, that means everything can be composed with itself and remain a function, right? So in that sense, it follows the rules of a monoid. And you can represent that as a single object like this. And actually in one of the texts I wrote for Crisis and Critique, I tried to go down this approach to describe the notion of capital as being a monoid from some set M back to itself. So then every commodity is a morphism. Then you can compose morphisms to yield. So like for any two commodities, you can compose them to yield some other commodity, right? But yeah, I mean, I think
the basic intuition, which I think it's cool to refer back to group theory, is that you do have something like a sort of structured space if you know that the operations that you can apply to it always yield something that is part of that space, and if there's something that functions as an identity in that space, right?
Mm-hmm.
So identity and closure do seem to offer some sort of operational version of unity, right?
Yes.
Also, I think to add the, I guess, idea of scale here again, right? With this like monoidal category picture, this is almost like the smallest scale, I guess. Because I like to think of the object as the tensor product itself. And then the arrows are going to be like the elements of the set. And if you go even farther out, the natural transformations, these ones down here, are like the algebraic rules that govern that space, right? And you can have more restrictions on it too.
Yeah. Yeah, I see what you mean. Yeah.
When you zoom out and look at the natural transformations between these arrows, then that's like where you see the like bigger structure of the space. That's like maybe what we would like normally when you do algebra, when you like do all the computations, that's sort of the scale you're on. So it's a sort of change of scale.
Right. Yeah, there's also a really cool, I'm just trying to find that picture.
While you're looking for it, I think that it's also good to stress this, which seems to be, let's say, the fountain where results don't stop coming for applied category theory, which is just the fact that category theory is so native to the idea of treating everything as composable, right? So this sort of statement you made, like players are games, or you can have games made of games, right? These two directions, which are, you can look at them in a way that doesn't imply some qualitative change, right? It is ultimately connected with the fact that objects and mappings are kind of the same, right? You want to define objects by mappings in such a way that ultimately an object is a certain space of mappings of certain property. So since the theory is already so welcoming to that perspective, that there isn't such distinction, it's easy to talk about, let's say, what composes an object, what are the mappings that make up an object, and what are the mappings in which an object is involved as being made of the same thing. So it seems like most of the areas where category theory is being applied today is to explore that intuition, right? Something that previously was treated as a sort of qualitative distinction between objects and maps, or agents and relations, it becomes very easily transformed into structures that are actually made of the same thing. They just have different functions in that structure, right? I think that that's like the underlying, that's also why it's so nice to talk about scaling in this way, because parts and wholes become totally relative, right? What counts as a part, like an atom or a unit, perhaps with a different perspective, you can talk about the parts that compose that part, meaning you're now treating it as a whole composed of parts, right? So it's very native to the grammar of category theory, it seems, to reconfigure everything in those terms, right?
Exactly. Yeah. Yeah. The whole part thing. I think it also, you know, it's very much relevant to this organizational point of view, where we're saying, like, to say everything is a form of organization is basically saying that everything's composable. I mean, if it's composable, you will get another form of organization, right? There's some closure to that statement. Yeah, but anyway, this crazy diagram here, it's just to show that it's supposed to show the artificial, I'd say, the artificial nature of this tensor product, because in actuality, these are all different objects, right? The vertices of this shape here, of this diagram, right? A tensored with B tensored with C is not the same as the other ones, right? Actually, in this case, this is a commutative thing, I think. But even for non-commutative, there's some what are called coherence, I think coherence axioms that have to be obeyed for us to properly make this system work, right? Yeah, so anyway, yeah, we can just trust that we can do kind of this algebraic move within this framework. Let me erase some of this.
Now, just one question.
Mhm.
There is one, I mean, we've been studying in parallel the whole thing with the resource theory and that it takes place in the symmetric monoidal categories, right?
Yeah.
But here, with the condition of symmetry is not necessary.
Yeah, exactly. Symmetry, I think symmetry means, and Yasha, maybe you can correct me if I'm wrong here. I think symmetry yields the commutative property for, so like A tensor with B is the same as B tensor with A.
Yeah, that should be it, probably.
Yeah.
If it's for a category, yeah, I think so.
Yeah, I think that's what the symmetry operation does. So in some cases it's not necessary, but I think in resource theory, it kind of is, it is usually symmetric. Yeah, I'm still not clear when the symmetric condition should be used.
So wait, in resource theory, what's the reason for the symmetry? Is it like everyone has equal access or something like that?
Yeah, I think it's just saying that when you take two resources and you treat them as one resource, it doesn't matter what order you do that in. But yeah, yeah, and only in special cases do you care about like the ordering of the, and it'll make more sense when we get to the string diagrams here, which is actually the next slide, right? So yeah, open games are actually a subset of a larger theory called open systems, which is very important for us, right? Open systems are defined on monoidal categories as, and they can be formalized or pictured as string diagrams. And within a string diagram, the objects of the category become the strings, and the morphisms are the boxes. So it's kind of opposite of how we normally think of these, right? And then there are both parallel and sequential compositions, right? Because of the tensoring being this new operation, it's very convenient because in a picture you can just put them on top of each other. Like A and B are tensored whenever they're parallel. And you also have the normal sequential composition, which is given by the fact that it's a category. So categories, you can do the same type of composition as before. So you get all these things. And then I is just an empty picture, right? Normally you don't draw anything. Or if you want, you can draw like this, I think. Just like a dot and a string here. So we can do some pretty crazy stuff starting from this formalism without even referring to the category you're in, right? You can just trust that if you're within a symmetric monoidal category, you get this pictorial formalism, and you can forget like the coherence axioms or whatever natural transformations and so on that are required to comprehend this as a category. So here is an example of the prisoner's dilemma as an open game. So it's a composition of three smaller games, right? Where player one is a game, player two is a game, and then this Q function that determines our payoffs is kind of the environment for both player one and player two. And so, this blue dotted line shows how you could cut this game into its parts, right? So this is nice, right? This gives us a way to think about this technological thing we talked about last time, where everything's just a form of organization, and we can connect these forms of organization together to form larger forms of organization. I think what would distinguish games would be a specific subset of organizations which have some kind of payoff function, right? They determine for some set of actions some utility, or whatever you want to call it,
But just one
output.
question, Dennis. Here I was a bit confused because isn't this the diagram for the prisoner's dilemma, right? The player 1, player 2, and then the set of costs for their decisions, right?
Yeah. Mm-hmm.
But I mean, you say that it's a composition of 3 smaller games. It's not in any intuitive meaning of game, because that would seem like the minimal thing I can think of as a game, the prisoner dilemma as a whole.
Mm-hmm.
Like, in which sense can we actually call Q by itself a game, for example, or one player by itself a game?
Yeah, I think the key is to consider a proper interpretation of the monoidal unit I. So if you think about the input and output of these strings, right? They carry some information to, let's say, the player. They also, in this case, there's some information going into Q. If you were to cut the string and separate them from the game, then you would be left with just I going into. So in that sense, it's a game because it's a kind of a trivial game because there's a singleton of information going into the game and coming out of the game. So it's like the player is left with 0 actions they can choose, right? I mean, they only have 1 action, let's say. And you always get the same payoff, which is just I again.
See.
Yeah. So you need some notion of the trivial game.
I see, okay. So it just degenerates to trivial games, but we still call a player that cannot do anything and doesn't receive any information as probably God playing a game with that person.
Exactly, yeah. It's like you're
it's the existential game, yes.
Yeah, exactly. It's like a Beckett game. Yeah. So yeah, so that's a good question though. Like I don't actually know how to interpret this trivial game. Like, what does it have a Nash equilibria? I guess there's only 1 action you can take and there's only 1 payoff. So that is
so my question is the following. It's not a matter of, let's say, slicing the perspective in the sense of the difference between looking at the prisoner's dilemma from the standpoint of 2 players having to coordinate or not coordinate if they defect or confess, but looking, for example, at the same games being played, there is actually there are 2 prisoners in 2 cells, but one prisoner doesn't know of the other prisoner. So even though you're making your decisions, and there are some decisions like I can defect or I can confess, I don't know that the other prisoner is actually caught as well. Like, it's not that sort of, it's not that sort of slice, because that slice says that even though I don't know where the inputs and outputs are going, they're still there. And what you said was actually the trivialization of it. Like the information is actually reduced together with the partition.
Exactly, yeah. That's a subtle point, yeah, because from the perspective of player 1, taken as this kind of mini game in it unto himself, yeah, he doesn't see the other player at all. All he sees is Q. And it's up to Q to furnish some information about the game back to player 1. So what Q is giving player 1 essentially is just different strategies, right? The Q, let's say, roughly stands for the police officer that says you're allowed to corroborate or defect, right? Collaborate or defect. I don't know, the C and D, right?
Mm-hmm.
Q gives you C and D. Q also gives you the payoff function, right? If this game were by himself, if this player were by himself and it was just disconnected from everything, right? We use the monoidal unit here. Then the payoff function would be some trivial payoff, right? But when you connect it to Q, suddenly the payoff function has, it's going to look like the one from, where did I write it? Here. Right. This is this payoff here.
Mm-hmm.
This is what Q gives us. Yeah, so if you think about it in terms of sets, maybe it's easier, like what is X and R and Y, X, R, and Y here. They're sets of information that can be arbitrarily, I'm not arbitrarily, but we can, you know, adjust the information. But that's just how these players interact with the outside.
Yeah, no, I think it makes more sense now. And it's also more, it looks weirder to talk about trivial games, but once you take the inverse route, it becomes much more interesting because the fact that, for example, if we plug more prisoners into Q, right?
Mm-hmm.
Suddenly things become more and more and more complex. You get that feel for, as if you're adding parts to like some circuit or something, and the weird feedback effects are, you know, might be disproportionate to the addition. So
exactly,
the other idea of, okay, considering smaller games is just focusing into a part of the whole is different from actually severing the ties and considering the part as a whole in itself. It looks degenerate at this small level, right? But since that produces radical effects, once you start adding parts to this structure, it actually has more, it says more, right?
Yeah, exactly. Yeah, I think a lot of stuff can be imported from topology, right? I mean, basically the whole idea of open sets and a topology showing how basically a closure under open sets in either unions or intersections, that intuition we can apply here. So in effect, this is a space, right?
Mm-hmm.
I mean, you can think of these as kind of like mini spaces or open sets, and then you combine them into a larger open set, and then this whole thing is kind of a topologized.
Mm-hmm.
Yeah, so a lot of that cool intuition is there. But yeah, I'm not sure, you know, again, yeah, I think there's a lot we can still learn on the limits of this approach. Let me erase this. Okay. Okay, but so I've shown how these games interact with each other, but actually within the game itself, there's some machinery happening. I think earlier I mentioned that in one of these ideas that idea 6, every game computes its own best response. So each game kind of has its own internal memory, its own internal state. It keeps track of what's happening around it. So if we look inside of the game, and remember, games are morphisms, but a morphism can itself have some state. I think that, and this is something that you don't get from any symmetric monoidal category. There's actually a theory called theory of lenses, right? And which is a concept from computer science that allows us to formalize this notion of state and updating state over time within a morphism. So let's just put that off, but that's the idea.
Hey,
so,
Dennis, I wanted to ask, with the idea of this like space of games and how you can combine game, right? Think of it as like a topological space.
Yeah.
What would an intersection of games be then?
Yeah, good question. I don't know. I think, I mean, I think you could say that like player one could actually belong to two different games, and like it's playing two different games.
I see. Yeah.
In this case, like this, it only has one input and one output, but you
Mhm.
could add other wires to this, and then then that would be the common game to the, or actually
Okay.
maybe
Yeah.
even
yeah.
yeah,
Especially when you think of games as always being made of other games, that makes sense. Because of the
Yeah.
player, right? Yeah. Okay.
yeah. That's a good question. I'm not sure when you would want to intersect. Yeah, because then you could do interesting things like cutting out parts of the game and then gluing the part together in a different way. Yeah, so we have this notion of X being a set of observations and Y being a set of choices, right? In this diagram here. So Y is the arrow flowing out here. Actually, I guess in this case, X and Y in this diagram are both actions that the player one is taking. But you also have this picture actually makes it clearer. So a game pictorially is represented as a box with arrows, the top arrow flowing from left to right, and the bottom arrows flowing from right to left. Okay, so let's just keep that image in mind. So X is a set of observations and Y is a set of choices that you can make. R is a value of utility, and S is a value of co-utility. And the S is the most confusing part, so we'll get to that. The other three kind of make sense intuitively. So every game keeps track of these four things, right? One is the set of strategy profiles, which are, like we said earlier, it's like assigning an action to every player. That's a single profile, right? So the combination of all possible actions for all possible players, that's what this symbol keeps track of, right? It's basically this table in normal form. That's the without the payoffs. So you have the set of strategy profiles. Then you have the play function, which takes one element from the strategy profile, so a single strategy profile, and it takes an element out of the observation, and it gives you back an action. So given what I know of different strategies and given my observations, like what am I seeing happening right now, I'm going to play a certain action. I'm going to send out some information. The co-play function takes the set of strategies, again, an observation, and the utility R, and outputs a co-utility. And so a co-utility is basically when you send some utility backwards to another game. So just like we saw with Q is a game. It takes in actions and it spits out utilities, right? Well, this actually happens for P1 as well. P1 actually, player one and player two actually are sending utilities out, but because it's a string diagram, we're actually abstracting that away. We're saying that the co-utility is going towards the monoidal unit, so it's kind of thrown away, right? So in other words, this, if you remember, this I means the monoidal unit, right? It's the object that if you tensored it with another object, you'd get back that object, the other object, right? So this is equal to this, right? Yeah. So in this case, sorry, it's flipped, whatever. But yeah, you understand, right? This should be this way.
So would you say co-utility is something like foresight almost? It's like after the fact, what would you have done?
No, it is more like your interpretation of the state of the game that you're sending to another game.
Ah, okay.
Yeah, you are computing your best response. That's the B, this fourth element here, in which case you're saying of the set of strategy profiles, if all the other players play a given profile, what is my best response? So there's some foresight happening in the best response function. I mean, you can be a really dumb player, or you can be some advanced AI or something like that. It doesn't really matter. You're defining your best response internally.
What's the right side of the best response? Is it like R given sigma?
Yeah, it's just a relation on sigma. So I think I'm not sure this is how it's written in the text, but I think it's
Is it like
more
R
like,
circle line sigma?
yeah, I think it's actually it's a subset of the product with itself.
Okay. Oh,
So,
it's like a rel. I see. Okay.
yeah, rel. Yeah, like relations.
Mm-hmm.
And then the reason you want to do this is you want to respond to a given set of actions. So if sigma is the set of all possible strategy profiles, then sigma times itself is, for every profile, your optimal response. Yeah, anyway, and we can actually interpret equilibria here as being, I think it's written this way, like if sigma and sigma prime and sigma double prime, etc., all belong to the big sigma, then an equilibrium is when the response to a given strategy profile is that same profile again. So this would be the set of all these would be the equilibrium set, which is a subset of sigma, or sigma cross sigma. Right. So if we think about this in let's say a computer science way, like or maybe even deep learning or machine learning, you're keeping track of different strategies and their payoffs, and you're maximizing, like with the argmax statement here, this formula here with the Nash equilibrium. You're kind of like iterating through all your responses, and you're finding the one that maximizes utility for yourself, given all possible other strategies that the other players have chosen. Yeah, and basically this, when you find equilibrium, that's when you get a fixed point on the possible responses, right? Where the response, the best way you should respond to this strategy is to apply the same strategy again. So there's no incentive to deviate from the strategy. So once you hit,
So the small sigma, this is going to be like the set of all responses from all the players, right?
yes,
So it's when everyone won't change. Yeah, okay, I see.
Exactly. It's not only your response, but it includes the best play of every other player. Yeah. So in that sense, that's also why players are games, because the player one isn't just calculating his own response, like I should do this when this happens. Player one is saying, given all possible actions, every player should play this, right? For any given context. So yeah, in that sense, yeah, every player is kind of coming up with their own game or their own perspective on the game. Okay, so the piece of technical wizardry that I can't really get into because I don't understand is lenses. Lenses allow us to do this backwards arrow. So when we compose the actions to the observations like this, right? These are observations, right? And then these are actions. We can compose that and it makes sense, right? That the actions of one function become the observations of the next function. So these are also observations going from the perspective of G. What is maybe not intuitive is this backwards arrow, which is saying G is going to give the payoff function for F. Right, but it's still compositional in the sense that we can add a further thing here. And now H determines the payoff function for G, called the co-utility. This handwriting is really bad, but yeah, co-utility here, and then co-utility. The co-utility of H to G is the utility of G. And the co-utility of G coming out of G becomes the utility of F. So there's kind of a dual thing going on. The same way that observations of one game become the actions of one game become the observations of another game, the co-utility of one game becomes the utility of the other game. Okay. All right, so that's pretty much all I have for open games. Yeah, the big intuition is that yeah, all the elements are games themselves. You can treat the environment as a game. The environment kind of abstracts away the rest of the other players, right? The environment is just a single game that gives you all the information you need about the other players. And then this environment can change. You can do things with this environment. And every game keeps track of its of a profile of a best response. Okay. So moving on to Edgeworth boxes. So yeah, before we go on to this, I want to be able to get to from open games as one of the tools that in our toolbox. I want to be able to get to a point where we can discuss the generation of prices, because so microeconomic theory, it gives us one piece of the puzzle because it allows us to get from preferences to a notion of optimal allocation, right? Given a set of individuals, and these can be people or businesses or any kind of property owners, given a set of preferences, we can compute a set of allocations, meaning like this amount of a commodity goes to this person and this amount of commodity goes to another person. We can compute an allocation which is optimal in some sense, meaning to deviate means it's going to cost someone something, right? Someone's going to lose if you deviate from that allocation. But that only gives us one piece of the puzzle. It doesn't really tell us where these preferences come from and how these preferences change over time. I think open games is a nice way to think about how preferences are determined, right? Because the whole metaphysical assumption of microeconomics is that preferences are somehow like this built-in feature of human desire, let's say, or what's called like rational actors, or human nature or something like that, right? Well, in open games, we have this dualism, like a human being is the same thing as a game, and a game receives its utility functions from outside, not from inside.
Actually, can you, because you mentioned this, I think it's very profound idea, but I'm not sure if I understood it correctly, if that's really the case, because you said something which is crucial to distinguish an actor from a player, because a player, in some sense, from what you said, it's kind of, as you said, like for a player to decide on a move is kind of to occupy the position that any player should occupy in that game, in that situation, right?
Yeah.
So there is a displacement from I'm an actor in a situation, which means I act in this way and maybe only I would act in this way, to a game where for me to act in a certain way actually means to think like anyone should in that situation, right?
Yes.
That difference is unclear in rational actor theory because it actually is naturalized in the sense that preferences and preference structures or strategies are supposedly, let's say, automatic, or they are natural, right? The thing about it that it's always the point where it seems to me to be the basic point of distinction between Marxist economic approach and microeconomic approach is that Marxism suggests that this point of distinction is objective. It's called value, right? The proportion between two things being exchanged is defined by an objective invariance, which concerns some real world process. Whereas in microeconomics, it seems like what allows for the commensurability between different things. So Marxism will say, and actually classical political economy more generally will say that you can exchange oranges for apples because they're both the product of labor, very vulgarly put. And the quantity of labor then defines the quantity of these proportions of exchange. So none of the terms is subjective, right? The things being exchanged, the proportions of exchange, and the thing that guarantees that they are exchangeable, they're all happening out there, right? Whereas microeconomics seems to start from a more subjectivist perspective, which says what makes oranges and apples exchangeable is that my desire for apples is qualitatively the same as your desire for oranges in some degree. And there's only the degree to be decided, right? The point at which we would make that exchange. But the commensurability between the exchangeables is guaranteed by the sort of innate abstract nature of desire. To desire A or to desire B, it's both desires. Therefore, A and B can be compared because this desirability already makes them commensurate, right? You see my point? Like that invariance that guarantees the homogeneity between qualitatively different things being exchangeable comes from the subject. Because people want different things are exchangeable.
Exactly, yeah.
Right, so whereas in one case you have labor, or we can define it in a different way, but it's still an objective thing, right? Like another commodity, apples, oranges, and something that also happens in the world just as much as apples and oranges that allows for them to be commensurate or measured in the same way. In microeconomics, it seems like there is this necessary intervention of a subjective domain to say, look, oranges and apples have nothing to do with each other. The only thing that makes them connected or compatible in some way, so that we can actually say, I'll give you 3 oranges for 1 apple, is the desire for oranges and the desire for apples. That's what's really guaranteeing that these things work, right?
Yeah, exactly. And that's what I was trying to get at when I was saying, what can we do to salvage the formalism of microeconomics? We have to, throw out some stuff, and that stuff has to do with this assumption about the source of homogeneity.
Yeah.
If we say the source of homogeneity is coming from the individual desire, that's the problem. We know the problem with that, right? It's that you pretty much say every exchange, like no one ever loses in an exchange, because if I exchange something, like if I exchange my labor for money, it's because I value the money more than my time. So in every exchange, both people come out of it better in every situation. But this is a very ideological perspective, right? Saying that every exchange is somehow fair, and that fairness is grounded in desire.
Yeah, and I think that it's even interesting that you lose once you have this desire basis for economy, which is the most intuitive one in a certain sense. It's also the most intuitive because it disappears with the problem of constructing commensurability. So you don't get accidental, you don't get the steps that we get with a value form of the accidental exchangeability and all the work that goes into making it into a global exchangeable space, right? Mm-hmm. So the fact that I exchange three oranges for 1 apple here, and then I can exchange it for, I don't know, somebody now I have 1 apple and I exchange it again for 7 oranges instead of 3 that I had, right? Inconsistent in that sense. That inconsistency is totally absorbed, and arbitrage is just, let's say, the fact that these exchanges are local, right? And we hope that inconsistency disappears simply by the fact that there are many people with many desires and some general equilibrium of preferences should appear. So it's not only that you treat actors as being the source of the homogeneity of exchange, but because it's a natural quality, you never need to explain how it got generalized. The only thing you need to explain is how much the quantities get stabilized, right? That they're infinitely commensurate, that's a given because people want things. Well, but in what proportion? Well, that then is the equilibrium is meant to decide, right? Yeah. And I think that this is what, if I understood correctly what you presented thus far, the big novelty is that if players are games, or if players have inner structure, right? It's not like actors are this innate machines looking to always operate basically the same general strategy, and they'll only take different tactics based on the best way to get what they want. but that there is something on the profiles of strategies that comes from the outside. You actually are, and that's why I meant by the statement seeming very profound, that to act like a player is not simply to act, is to act within some parameters in which anyone would act like that in your place, right? You're displacing from a natural position to an abstract or constrained position, right? A player is not simply doing his thing, right? It's already acting in such a way that anyone in your place would do the same.
Mm-hmm.
So the moral aspect is clearer, right? For example, or the normative aspect of something that usually treated as a natural disposition.
Yeah, that's very interesting. Yeah, it's all
See my
it's
point,
a bit
like
a Kantian, like what should I do? Take what I do as a law, right? In the form of
you
law.
invert that a bit, because now in the case the law comes from the outside,
Mm-hmm.
right? Some structure behaves like a player insofar as it gathers information about the game that comes from the outside and answers back in some way, right? That's how I understood the co-utility arrow, right? You're not only informing the game, but you're informed by it. So there is no sense of defining the player outside of those two arrows, as if there is such a thing as a autonomous actor, and you're just plugging him in to some conditions and he's going to choose. What it means to be a player seems to be more entangled in the system, in the open games approach, right?
Yeah. I mean, but this is not also to say that we cannot model things like, for example, corruption, because you know how we could talk about corruption or like let's say I give you some money to go and buy something for me, right? So there's me here, and then say you are here. We're both games. I give you some money in the arrow going towards you, right? It's an observation that that you get, and then you take that money and you go to the store and you buy something. The co-utility is actually what you decide to give me back. Like, well, let's say I ask you, oh, also give me back the change from after you spent the money. Give me any change you have left. It's actually up to you, the game, to deliver back some co-utility back to me. I don't actually know how much the thing costs, right, in the store. So I don't know if it's corruption necessarily, but let's say you have some freedom here to decide what co-utility to deliver back to me. So you can actually model, let's say, behaviors that are not necessarily
good faith.
In good faith, yeah. I just want to point that out, because it's not like we're treating every player like some kind of purely rational unit. There could be different forms of rationality embodied in the game. I don't know if that changes. I think it doesn't change it, because we still are saying it's an objective function, not based on subjective preferences, right? Right. This would be kind of a middleman game. I don't know.
Yeah, but I think that usually is. For example, Mancurosen with the free rider paradox is kind of exploiting that, right?
Mm-hmm.
The fact that people who are in the middle of organizations, by being rational, end up having less incentive to contribute to the common good, because they extract more from it than they need to put in. right? That sort of very common problem where a bit of people do a lot of work. So other people in the same organization feel like, okay, it's rational. It's not like, again, it's a bad faith based on the same principle of maximizing profit and diminishing losses, right? If I give very little in, I'll still take a big chunk out. So there's no reason to give more, right? So he shows this sort of internal, he kind of connects the Pareto distribution, right? Of 20 people doing 80%, 80 people doing 20%, to this sort of free rider structure that doesn't contradict the rational actor theory. But what I was saying before, which I think is slightly different, but now I see that I didn't understand this co-utility thing that well, and I don't think it's actually perhaps connected to it. But it seems like open games, because there is no black box to the actor, I think that's basically the point, right? Formally, there is no reason why an actor should be a black box, because there is a position with regards to a larger game, which makes a game into a player, right? It kind of it doesn't allow you to have that sort of underlying commitment to some homogeneous decision structure that is guaranteed for everything. That actually becomes something you need to spell out. Yeah,
that's unique to, or that's determined by the parameters of the game in question. I mean, and in the end, like this formalism of open games is meant to encompass everything you can describe with regular game theory anyway. But it's just in a way that you build this up, and we can see generative effects from the building up of games, right?
Yeah, but,
just like we saw with IIT, just like we saw with like compositionality text, or the generative effects text, right? That by combining these games together, we get phenomena that are not predictable from the individual parts.
This might be completely out of hand. I mean, completely wrong. But while I've been paying attention to what you're saying, Dennis, and it strikes me somewhat as similar to what my very rudimentary understanding of linear logic or ludics or something like this.
Yeah. There is a connection. I have no idea about that stuff, but I do know that linear logics, or the guy who made that uses, or it can be formalized in symmetric monoidal categories.
Exactly. And there's this business also of treating the environment as a player as well. You can treat the environment as a player, and it's basically an interactional paradigm between, actions from one side that become resources for the other side. So it has some resemblance to what you're saying. I don't know really how to make it explicit formally yet. It's something that I've been studying for a while, but maybe it might be some interesting area of study also for us. I mean, because
what I know of this, Caron, is that a symmetric monoidal category is a sort of natural place to do two things that connect very nicely. One is to map it into that Boolean space of truth values, but you can also give it a cost function. So rather than treat propositions as true or false, suddenly they become resources for other propositions.
Exactly.
Right? And then you can further constrain it, and you can actually define a logical space. I mean, there's that famous Girard sentence that linear logic is about food, not about truth.
Yeah, exactly. Yeah, I was thinking about that. It has some resemblance to what's being said. It's not really the same. It seems not really the same formalism, but it has some properties in common. Might be something to look into a little bit, I think.
Yeah, I definitely want to explore that that connection. Yeah.
I think that for us, I mean, in the bigger project of let's say talking about the epistemological value of organizations and economy, the interesting path is the inverse, because ludics is mostly connected with moving away from a sort of truth-based approach where propositions are evaluated purely by their sort of rational truth. And
Yeah, truth values. Yeah, bipolar truth values. Yeah.
yeah, and move to a space where propositions are treated as resources. You don't want to copy propositions. It's like an economics of truth, right?
Yeah.
And it has that interactional aspect. But for us, the interesting thing is the opposite, which is given a certain economical space, you can actually treat cost functions as truth functions. Meaning, cost functions are more obvious for organizations. Like this is costly, this follows from that, this belongs to that, or this is conditioned on that. The fact that you can actually go back and this can actually revert to, for example, something being true, something appearing as true because of it costing this or that much, right? In terms of the amount of resources it consumes, right? That's actually a very Marxist idea, right? Labor is cost-free for a capitalist. You buy labor power, but you actually are using something that you didn't pay for, which is a certain labor capacity, right? For Marxism, a truth proposition there about economics is a proposition about that takes into consideration the real cost of labor. So a system that can see the real cost of labor is actually saying something more true than a system that cannot evaluate the real cost of the labor employed. So there is a weird connection between cost and truth values that I think that resource theory is exploring, ludics explores in a slightly different way, but it all departs from these symmetric monoidal categories and how powerful ordering processes actually is as a formal tool.
Yeah, what you said gave me this idea also, like if we wanted to count something that was not counted before, right? With open games, that's a very natural thing, but you just need to add another game, right? So like if labor was not counted before, we can now add that as, I don't know how you would formalize it, but like we could add another game that somehow modifies the information that flows into our original game. And then suddenly that changes the best response strategies of every, let's say, every company or every firm, right?
I think ecology is a good example of this, right? It's very much on the table today, the idea of stock stakeholders and the fact that you should consider natural degradation as, so the environment is actually playing the economic game, right?
Exactly, yeah.
And
if the economy is a game, we could add, actually the arrows are backwards, but we could add the environment as another game here.
Yeah, and then I mean, what I want to suggest is that if you exploit this difference between the cost of certain processes, because once you realize, let's say, cost is defined, from what I understood thus far from this stuff, cost is defined at, right, it's just in the sense of, let's say, if A is smaller than B, right, you cannot get B without getting A. So A composes the cost of B. But there's also things that seem like they're the beginning of a process, right? Like this.
Yeah.
So
those are that's where the monoidal unit comes in.
Yeah, exactly. This is like this, right? So for example, to reveal that there is actually a cost here, right? And that A is actually including something else that comes before, you're actually changing the structure of this proof, so to speak, right? So there is actually a correlation between the ordering of these processes, assigning to them a cost function, which is usually just some metric with the reals, right? And assigning them truth values. Like you can play with that similarity. And I think that that's actually a nice intuition for what we spoke of in other moments, where like, what does it mean to suggest that political organizations can probe into social space and acquire more information about it? Well, that implies that something about the reality of organization is connected with the reality of propositions about reality, right? That things that I can say because I'm organizing might be true, and the truth of that is connected to organizing. I think that this connection between cost and truth values is a very natural, very interesting way to exploit that, because it's saying that once you realize certain things are very costly, right? For example, this can be totally general, like cheaply generalized to discuss political analysis. For example, somebody says something like, everyone on the left should get together, or all oppressed people should get together. This seems true. But once you try to organize, and the cost of doing this, meaning the actual connections required to arrive at some level of unified organization, are actually kind of disclosed, right? These people need to get along with those people that need to get along with those people. And if these people get along, they won't, that other person won't get mixed with them, and so on. And this starts being constructed. You actually get, let's say, effective sense for the actual truth value of that proposition, right? People should get together. Yeah, but this doesn't simply mean stating it, doesn't mean, you know, getting to it somehow. So I don't know, it seems like a nice direction to take this, you know?
Yeah. Yeah, I think another example could be maybe like talking about what is feasible in a world, right? The term feasible,
Yeah.
it's very loaded because it implies a certain state of affairs in terms of like what is costly, what is not costly, what comes for free, and what costs a lot. So when we say like, oh yeah, you know, like solving the environmental crisis is not feasible because you know, it's going to cost too much money, or it'll you know, crash the economy or something like that. Then, but you can always come back and say, well, the cost of not addressing an ecological crisis would be even worse. But when you do that, you are implicitly invoking a different game. Let's say you're invoking a different payoff structure. So I think, yeah, it's not. I think what you're saying about like mapping these open games to a true and false structure, it is like saying, you know, defining what is the set of feasible actions or feasible behaviors.
Yeah, I didn't get to read about that, but in 7 sketches on compositionality, they have a chapter on feasibility, right?
Mm-hmm. Yeah, it's a good reference. Chapter 4, I think. Okay, so yeah, the second part has to do with this microeconomic stuff that, like we said, we have to take into account what it means to have preferences and so on. But you know, given those kind of ideological issues, I think we can get a lot of value from this formalism. So the first formalism is called the Edgeworth box. And it's basically a kind of a geometric intuition for equilibrium and allocating resources. So in a 2 commodity, 2 owner system, so there's 2 people and 2 commodities, and assuming a finite quantity of this commodities, let's say they're both have n, we can create a square, or what's called the Edgeworth box. And actually, the n doesn't have to be the same for both commodities. I think you can have one commodity. It's like 1,000 units of trees and 200 units of computers or something like that, right? It doesn't have to be the same, but in this case, let's say they're both n. Then you can draw this box where the left axis and the top axis correspond to player 1, and the bottom axis and the right axis correspond to player 2's ownership of given commodities. So you have to kind of flip this around to see both sides, but the intuition is that an allocation is this green dot, and it specifies how much of commodity A that P1 owns, how much of commodity B that P1 owns, how much of commodity A that P2 owns, and how much of commodity B that P2 owns, right? That's all of that is captured by a single point in this space. And if you imagine moving this point in the space, you'll see that, just imagine moving it left and right. If I move it to the left, that means I'm taking some of the commodity that P1 owns, and I'm giving it to player 2. And vice versa. If I move the point to the right, then I'm giving some of the commodity from P2 back to P1. Right?
Always commodity B, though.
Of commodity B only, if you're moving left and right. If you're moving up and down, then you're affecting the distribution of, sorry, I think I flipped that around. Left and right is commodity A, sorry, because the axis is you can see 0 to n at the top, right?
Okay.
So yeah, left and right here is commodity A, and this is a commodity B. Yeah, so if I move it left and right, I'm changing the value of commodity A for player 1, and I'm giving more to more or less to player 2 of commodity A. Similarly, if I move up and down, I'm changing the allocation of B. So this is a kind of a zero-sum space, right? If I move this green dot all the way to the bottom right, that means I've given all of commodity A to player 2 and all of commodity B to player 1. And vice versa if I move it to the top left. So the corners represent, like, I've given all of one commodity to one person.
When you say it's a zero sum, it's simply in the sense that the quantities are maintained. It's just the ownership of them that moves around.
Exactly. Yeah. I'm never adding more of the commodity or subtracting from the set of commodities. I'm just changing the allocation. Okay, so hopefully that makes sense, right? This is a very simple system: 2 commodities, 2 owners. So the problem is, how do we generalize this to an actual economy, right? There's some geometric intuition that extends this notion. But before we get to that, with a given Edgeworth box, we can describe what are called indifference curves, which are these kind of emanating from the bottom left and the top right. I left out the axes here, but just imagine it's the same, like, commodity A versus commodity B situation. And I sent a video earlier about what indifference curves are, but just a quick summary. Indifference curves basically describe in this space what's called the marginal rate of substitution for a given commodity. So each line, each curve represents a single utility. Let's say the utility is 100. And if you travel along the curve, meaning if I had a point on the curve and I move that point along the curve, the utility will not change, but the allocation to that person, to that individual would change.
It means that I'm indifferent to having some amount of commodity A or some amount of commodity B.
Exactly. Yeah, let's say I had 3 units of commodity A and 4 units of commodity B. The indifference curve says like, okay, I'm willing to give up, let's say 0.5 of commodity A, as long as you give me actually, as long as you give me a full unit of commodity B. Right? So I'm saying whether you give me 3 units of A and 4 units of B, or you give me 2.5 units of A and 5 units of B, I don't care. I get the same utility from each.
Mm-hmm.
And because of the structure of a rational preference tree, this is like a kind of a smooth curve, right? This is a differentiable curve in some space. So there's this kind of calculus stuff going on here that is the mainly it's a convenience.
Yeah, I see. You can always take the area there for any point on it continuously.
Yeah, and yeah, that's another thing. At any point here, any allocation in this box, it lies on a indifference curve. Like I didn't draw all of them because there's an infinite number of indifference curves, right? But even this this one here, this green dot, it actually does lie on an indifference curve. And if I move this green dot a little bit, it would also lie on an indifference curve. Right? These curves don't always look the same.
Why does it have to be continuous, right? Because can't you have like non-infinite like divisibility of whatever utility it is?
Yes, that's a good point. So yeah, like an example, if I have a cow, I can't exactly cut. I mean, it's not valid to like cut off a piece of the cow and say like I'm indifferent. Like I could give you the leg of the cow.
Yeah, 1 cow, 2 cows, or 1 cow and a half.
Yeah, at some point there's like a qualitative like distinction, or like there's certain commodities you can't like cut infinitesimally, right? They're not infinitesimally structured.
Mm-hmm. Another reason I was thinking about this is it was kind of reminding me of if we apply an idea of scale to this again. I know I keep saying this, but this is reminding me from that book, the Natal book, The Relativity of All Things. So like maybe you imagine that rather than like this being an individual, like an Edgeworth box for individual actors, it could be like for communities or states or something.
Mm-hmm. Yeah.
And there will be some sort of like, as you go to the scale of the individual, this will like break up in this kind of, and like new structure will emerge. It won't just be like continuous, you know?
That's a great point. Yeah.
Yeah, that's this whole idea of like fractal scale relativity.
Yeah.
Right.
Yeah.
Yeah, this is an ideal case, and you could say, like you said, it gets approximated by very large sets of commodities and individuals, right? Like most of like for an actual person, it's going to look a lot more jagged or more discontinuous. But in the limit, let's say, in perspective of like a state or a large organization, these curves start to be smoother.
But you said something now that actually I never thought of, but it makes sense. It's like, I think another principle that goes very closely related with the idea that rational actors guarantee the homogeneity of exchange is that everything that exchange is an actor in the same way. Whereas this weird shifts in scale, they all need to happen at the level of commodities. So demand and supply gets to be complex, but a person, a company, a country, they're always punctual. They're always structureless in that sense. So you can always move between scales because every time there is an actor, a government or a person or a company, corporation, right? They are just without content, right? There's no inner structure that can change something about them. If you come into a bargain, you're an actor, right? Whereas in Marxism, that's not really the case, because to exchange as a private property owner, to exchange as a capitalist, to exchange as a company, it's not the same. Not only because commodities actually remain pretty similar because exchanges remain 2 by 2 and things like this, but the transformation, the sort of scalar transformation goes everywhere at the same time, right? Something we've been looking at, like the notion of price at the level of individual exchange in a very small system doesn't mean the same thing as price means if you take a very complex social system where prices are no longer representing merely the amount of labor time that went into something. They're already including the profitability rates based on total average of society and things like this. So actors move, the structure of actors change together with the scale, whereas it seems to me that in microeconomics, actors remain kind of structured always in the same way. It doesn't matter how complicated the market game is, I'm sure if that makes a lot of sense, but it seems like something like that.
Yeah, that makes perfect sense. That's like what I was saying.
Yeah, I think we could talk about introducing some kind of scale relativity, right, to this picture.
But one thing I wanted to understand before any crazy business, any shenanigans is, it seems to me like you have I'm not sure if it's because of how much richer it is in terms of formal resources, because much more work has been done with microeconomics and mathematics than in any other heterodox economic theory. But it seems to me like to have a sort of underlying intuition that the microeconomic approach has something to offer that we should keep, Like, do you have any clarity, or you could say a bit about that? Like,
yeah, I think we are at a point where this stuff touches on Marxism because we have talked a bit about like attractors in the economic space, right? I think there is something about microeconomics that does capture the structure of attractors, of why it is that prices or economic situations tend towards some kind of state.
Yeah.
And this is part of Marxism too, right? Like the falling rate of profit and crisis and so on. Those are also attractors. So,
yeah, but the thing for me that I can't really get over yet, and it always kind of gets to me, is that there seems to be a trade-off in microeconomics, which is, look, you get to model very complex phenomena with very cool tools if you only accept that, let's say, the phenomenology of markets is the phenomenology of market actors, right? So what is taken to be the objective standpoint from which things appear, and then which needs to be taken therefore in account by the model, is the standpoint of actors, like what Hayek called the man on the go, right? And the sort of, as we are talking here, like starting from people who own things, and then they meet and they want to exchange, and their inner preferences, like this is taken for granted as relevant economic facts, right? Whereas in Marxism, the hard thing is that the objective perspective is supposedly not your perspective, is not the experience of markets, right? The experience of people meeting and forming contracts of property exchange is deceiving for Marxism of where the actual social phenomena are and how they are taking place. So you're asked to remove yourself from your perspective as an actor to be able to see something rationally, right? Whereas in microeconomics, I think it's very tempting because it's more like a classic phenomenology. It says, look, you're a subject of the marketplace by having preferences, by wanting things, and those are relevant economic phenomena, right? And it seems to me like when we were talking about players just before, it seemed to me like there is a little hint of how you can actually account for this within the Marxist perspective, which says that there is a displacement, an objective displacement you need to make to turn your experience into actual social phenomena, right? To remove the mist and actually see things that are relevant economically. Because there is this, you even wrote about this, I think, that there is this sort of feedback effect about microeconomics, which is, it's saying it on one level, it's saying people act in this way, but on the other level, it's actually a normative theory that says, look, people act in this way, so you better also act in this way, right? If you want to be able to be a good agent. So on the one hand, it seems like it's descriptive, but there is a feedback between the descriptive and the prescriptive. It's just that the thing that is made objective is you, right? It's the same time that it's this modeling social reality is modeling the actor of social reality. So it's giving objective content and rational justifications and moral justifications at the same time that it's describing how phenomena work. Because the more it describes, the more it's telling you between the lines, look, I'm telling, like, this is how people are behaving. I'm modeling it starting from presuppositions concerning human nature. So you better mimic that human nature yourself. So there would be an objective phenomena, an objective displacement of perspective. It's just that it's an objective displacement of perspective concerning your own position rather than concerning, you know, commodity. If this makes sense, I'm not sure if I'm making myself clear, but if this makes sense, I tend to agree that there's something very interesting and profound that you can extract if you use it in an interesting way, which is nothing prevents objective phenomenology from going a step further and asking the question not only about how do you displace your perspective to see commodities for what they are and to see their logic and to see value, but then the other inverse question, which is how are people and their experiences remapped, right, from the perspective of that kind of more autonomous social structure, which seems to be what microeconomics does between the lines, like.
Yeah, I think no, it's really good points. Yeah, I think that's exactly, like, it's a more elaborate version of what I've been trying to, like, the reason I don't want to give up on this formalisms is because I think with the proper interpretation of the source of these lines, basically these indifference curves and or whatever phenomena that we're studying, if we interpret it as in the proper objective way, we can kind of make these work for us, right? For example, instead of using individual preferences, why not use profitability or the valorization perspective as the source of preferences? So I prefer A to B if A will make me more money than B, right? If A is a part of a capital, and that capital yields more profit, then that is an objective function, not something like about individual. Not something about the individual. Yeah. So yeah, I think there's some tweaks we have to make there to make that more acceptable. But I don't think like inherently these tools have to have that baggage.
Yeah, I'm sorry to get sidetracked on this, but it's just that it seems to me that this is the sort of thing that the game approach of a larger game perspective is interesting, because you can then include the fact that the more your strategy profile is confirmed in real world, the more it's confirmed to you that that's the actual game you're playing, right? So
yeah, I see your point. Yeah,
that's the sort of thing that I'm interested. And I think that shouldn't be taken as ideology. That should be like, oh my God, so capitalism makes you think you're a rational agent, and this is just reproducing ideology. It's actually an empirical test, right? I behave as if people have rational agency and preferences. Well, if that works, that confirms my assumption, right? So you get a feedback of that belief that confirms that this is the game being played, that confirms that that's a good way to continue to act. Like that sort of feedback structure, which again changes you from an actor into a player of a game you don't know the rules of, right?
Mm-hmm.
So sort of inquirer into the economic game. You play it under certain assumptions. If they give you like we would have to the truly rational theory, the Jamesonian rational theory, where cognitive mapping is included. It's minimizing loss, maximizing gains, and knowing the game you're playing, right? Like you actually would have three things you're trying to assess in a strategy.
Exactly. Yeah, because right now, yeah, with regular game theory, you assume kind of a flat space for games, like all the games are the same, that there are no generative phenomena, and you can kind of discover the game you're playing just by local feedback of your actions. Like you said, like you do some stuff and you are rewarded for it, therefore you must know what the game is, right? But if you kind of embed that picture, if you embed that game within a larger set of games, there could be a whole class of games that give you the same local response, but globally are very different games.
Yeah, and I think that's exactly what happens with rational actor theory, because the more, that's the base principle in which sort of liberal worldview is based. Like, let's say the concern with your local preference will be stabilized globally in what's best for everyone, right? So you don't need the idea of social responsibility, because in the averaging of individual responsibilities, right, and the concern for individual responsibilities gets us to the best possible situation. Of course, this can be amply complexified, and we moved past from the idea that there's one point of equilibrium and therefore it's the best point, because everyone being bad is also a point of equilibrium. So it's not necessarily the best situation, but it gives a different and nice explanation as to why. Let's say if you're playing, let me put it like this: if you assess rational actor and game theory from the perspective of only minimizing loss and maximizing gain, you can see a contradiction, because locally you're doing your best, but you might be creating the conditions that are the worst for you in the long run, for example, right? Local preference and global preference, or local preference and a preference in a different time resolution, they might not match.
Yeah.
Right? But if you include the mapping variable in every strategy, right? I'm not only looking to maximize my gains, but also to know which game I'm playing. Meaning, mapping the space of games is part of playing the game.
Yeah.
You can see that rational actor theory offers one thing that many other moral approaches don't, which is it is transitive for every situation, right? At least it defines the game you're playing in such a way that for many scenarios, it kind of gives you back what's kind of roughly expected, right? Because it's tapping into what we call mode C, right? It's tapping into a very, not mode C, but a very specific connection between property relations and market relations. It kind of holds as a consistent approach and many places, right? Whereas, for example, sacrificing something of your preference in favor of someone else might make sense in your family and close friends and loved ones, but suddenly if you try that out somewhere else, not only will you lose something, but you also get the feeling that that's not the game that is being played, right? So you don't get a good lens to map the world, so to speak. So I don't know.
Yeah, I see.
Slightly different. I mean, it's a way of taking seriously rational actor theory, but and the sort of economic game theory for microeconomics, where you're actually redescribing why it is so effective, rather than simply taking it to be effective because it's describing the world, right? It's effective also because it is a description that kind of confirms itself to be a good description as you go along.
Yeah. Assuming the structure of the games you're playing.
Yeah, something like.
Yeah, I think it fits basically with the basic intuition we've been having. Like, you know, let's assume this box here, this Edgeworth box, is a local patch of some much larger space, a much more complicated space. Yes, this patch may assume a certain equilibrium, which the next slide will talk about. But if you were to embed this patch of space into this larger patch, you would see that this local equilibrium doesn't translate to a global equilibrium.
Mm-hmm.
And so finding the right cognitive mapping, finding the right what game you're actually playing is like projecting this map into different larger spaces. And that's a political project, right? That's a larger organizational goal, because it's also maybe even constructing games as well. Not only like discovering what is the game, but building the game or adding to the game in some way, because you're the same thing is true about open games, right? You are a game that's influencing other games just as much as you are a player playing a game. Right, you not being necessarily the individual, but also whatever organization you're a part of. You are an environment for some other game. So yeah, there's that kind of back and forth that we can embed this into.
And I think that this is a nice way to talk about exchange in what we call last time the sort of vulgar space, right? Where you are not guaranteed that there is sort of underlying homogeneity in the world. And I mean, I'm just thinking that, for example, if you imagine that you had to include in this sort of preference structure and the sort of points of allocation, right? Not only the moment where quantities are coherent, so I'm indifferent to exchanging this amount of what I have for that amount of what you have, and there is some variability that is invariant for that exchange. But for example, if you need to make explicit the idea that it's part of playing the game, the information of what game you're playing, it might be the case, for example, where an equal exchange is interesting because at least establishes what game is being played between the two parts, you know? You see my point? Like, it's a way of talking about, for example, exchanges between communities that never met, right? It's not only that I want what you have and you want what I have, but the fact that we can exchange is also establishing a bond. So it's creating the common space between the two. So you're not simply exploring the fact that there is this common world called exchange, and that we are all naturally prone to it because we naturally have interests. But the moment that we find the common game we're playing, we actually establish some local commonality there, right?
Yeah, I see. That's an interesting concept, because that's like saying the very fact of exchangeability is itself kind of a resource.
Yeah.
Of it on its own. Like the fact that I can exchange with you, regardless, even before the individual things we exchange, the particular things we exchange, that channel of that the fact that the channel is open is a
Yeah, that's what Wittgenstein called agreement in forms of life.
Okay.
But you see, like I think that with open games, this idea that, okay, there's no reason why players should be a black box, and that we can actually spell out what composes a player, and players having that slight difference from actors in the sense that players are kind of constituted by the games they're playing. That all kind of opens, it seems more cogent to that perspective, you know, because, for example, with that co-utility arrow, you said, the guy doesn't give me back what the change for the money I gave him, right? But everyone knows that the mafia uses this sort of thing to learn who you can trust and who you can't, right? You give somebody a task, which is actually a false task, or it might be a true task, but it's not that important. And then if they don't execute it nicely, or if they do, that information sometimes is more valuable than the task being properly executed.
Yeah, that's a good example. Yeah.
You see my point? Like, I mean, everything you're saying here, I hear as if you're using Omar's voice in The Wire. Like the game is the game. So I went there and they do this with a guy they're not sure of. They said, take the drugs to this guy, and they want that to happen. But even if it doesn't happen, or if it happens in not the best way, the information about, okay, how much is this guy playing the same game, or what game is he playing? That's actually a relevant question.
Yeah, I love that. The Wire is the ultimate game theory.
Yeah, I think so. Like for me, The Wire, everything is explainable through The Wire.
Yeah, because it does show there's like an isomorphism, or like the game that the police play. It's not so much different from the game.
Dude, and even if you, okay, you open that door, right? I just gave you the hint, but for example, Avon Barksdale, the first drug dealer, he's clearly mode A, right? It's family, honor, blood ties. People will betray him from his family, but he will stick to them. Then you get the Stringer Bell, who is like market, but at the same time, kind of, you know, property relations, social contracts, let's keep things in order, monopoly of violence. It's like mode B. And then you have like Marlowe, who is like impersonal, like capitalism, but totally, you know, destructive with no remorse and no common, it doesn't keep to any pact, you know, and you get mode C. And then you have Omar, his point is precisely this. Like the game changes. You need to know how to evaluate. Like something is invariant, but that doesn't mean you'll know how to exchange with people all the time. You need to actually assess it every time you go, you know?
Yeah, I would say, either Omar or Bubs, the homeless guy.
Yeah, the homeless.
I think,
yes, I agree with you.
They both, they fit this kind of in between status of worlds. Yeah.
Yeah,
that's a great point.
Yeah, we could do the wire discussion one day. I'm not sure if everyone saw it, but it's the best thing to exemplify everything.
So I think there's only a few more slides left. Let's just get through this next few, and then we can revisit these topics, I think. So yeah, I mean, we defined these indifference curves, right? And we said that every allocation lies on some indifference curve. And so we can define these special points in the Edgeworth box as points where two indifference curves are tangent to each other. So you can actually imagine in this case that every point in this green line is actually a point where like this is happening, right? Right. Obviously, we can't draw all of them because there's an infinite number. But if you were to connect all of them together, you would have this green line. And how do we interpret this contract curve? They're the points at which the allocation, once you reach that allocation, it would, to deviate from the allocation, would cost the utility of one of the two players. Right? So it's optimal in the sense that once you've reached this contract curve, once an allocation falls within the contract curve, to deviate from that is to cost, or is for one of the players to lose utility. So this is what basically market efficiency, or good outcomes of a pricing model and so on, they all rely on this kind of theory, right? That there exists some optimal curve in this space. And remember that we're dealing with a two-person, two commodity system. So it's a very small system, but we can actually generalize this curve into higher dimensions. So we can think about a space where there are many property owners and many commodities. And then this single line curve becomes the intersection of a bunch of surfaces. So yeah, I mean, really hard to visualize it, but I think it's a nice intuition for what efficiency or optimality means in the market context, right? And there's actually a term for it. It's called the market core. Right? The core is a surface. It's a shape in some n-dimensional space, and allocations that fall on that surface are optimal. So there can be many allocations that are optimal. They're basically the ones that give the best outcome given everyone's preferences, right? But we can also interpret them as being kind of the attractors. Once you get into an optimal allocation, it's very hard to get out of it, because to get out of it means to make one of the actors lose some.
Hello?
Dennis, you cut out.
Yeah, Dennis. Hello?
Still in here. I don't know if you can hear us or not.
Yeah, he dropped now.
His internet must be out.
Yeah. But I mean, I really, I find this, I mean, everything I read from it, if you abstract from that issue of, okay, what is, like, what is a, yeah, he's coming back, I think. What is your individual preference and things like that? If this is kind of removed from the picture, it's always such a nice kind of clean construction, you know, the basic building blocks of it. This idea of people meet, they want certain things, and you can actually calculate the best deal, right? But I find it so weird to, I mean, I don't see any, it's almost like I don't even see anything economic about it. Like Dennis, I was just saying, like,
what was it?
No, I was just saying that it's weird, like you're talking about now, the Pareto optimal point and things like this. And it's weird because it almost seems like microeconomics is not really formalizing anything about economics, you know? It seems like it's a theory of interests. Like, let's say you're not talking about markets of things, you're talking about, as they call, the market of ideas, right? And I have certain arguments, you have other arguments, and we come to an agreement. And that agreement considers, let's say, how much I'm willing to concede and how much you're willing to concede. It seems like you would fall into a similar approach.
Yeah, exactly. It's the same thing. Yeah.
And I mean, that, no wonder that they use the same metaphor, market of ideas and things like this. So ultimately, it doesn't seem like the thing being modeled is, let's say, the conditions of real life existence at a given time. Because I think that's where what Marxism is trying to do. Like, it's kind of about the conditions of survival in a given moment. Because, okay, we talk about labor determines value, but yeah, but the value of labor is actually determined by conditions of survival. It's not determined by preference, right? Whereas in this case, it seems like you're I need to make you co-host. Like, it seems like you're starting from, I mean, if the thing being coordinated is actually preferences, right? That's the infinite thing. People are always dissatisfied. They always want something. That's actually, we talk about scarce resources and how microeconomics would be more down to earth because it starts from scarcity. It doesn't start from scarcity. It starts from the infinity of preferences. People always want more. Like, that's essential to it, right? And then there will be some objects you kind of sprinkle on top of these curves of preference, and then they fall where the preferences are, not the other way around.
Yeah, that's the most, it seems like the most metaphysical part of it is like, what is a preference? It's in a lot of ways, it's just whatever the economist needs to make this, make the mathematics work, right? It's like preference is basically a smooth curve in some high dimensional space. And you can intersect these curves and you can find a curve that touches all these curves, something like that, right? And so, like, what does that have to do with people surviving or doing what they need to survive? Yeah, I agree. I think Yasha made a good point. Like, if we take the right scale, like this only works if we look at things at a certain scale where because that's kind of what we said money does, right? Like, money turns things into like a continuum where you can slice, like labor hours can be sliced indefinitely, and every slice of a labor hour is itself a labor hour, right? Not hour, but every slice or duration of labor is itself a commodity.
Mhm.
I think something like that is also happening with utility, right? The notion of utility and so on is like a continuum. In reality, it's not, right? Like many cases, it's survival, for example, is not it's not on a continuum. It's either you did survive or you did not. So yeah, I don't know.
But what I'm starting to see, like with this, I'm sorry also if we're getting too kind of caught in this different direction, but what I'm starting to see that is the sort of thing that we should learn about and then try to emulate, or at least ask how this fits into any other perspective, which is that if you take that hidden variable out, meaning if you consider game theory from the perspective, economic games, from the perspective that the question of what game you're playing is part of the costs and benefits of games themselves, right? This is something that Marxism is not concerned with. Like the theory of fetishism, the theory of money, Marx doesn't even try, like he only has one moment that I know of in Capital, in the first volume at least, where he will mention how all of this structure maps back onto experience, which is when he's talking about the person who hoards money. And he says, keeping money in your house makes it look as if you're aesthetically connected to something infinite, like because money could be anything. So when you see money, you're looking at the whole, right? It's the only moment where he mentions something like this. Whereas microeconomics is constantly, whether it wants or not, constantly remapping economic categories back to the scale of experience, right? And back to the scale at which terms like preference make sense. And on the one hand, it is, let's say, highly ideological, whatever, but on the other, it does something which I think Marxism is incapable of doing, which is it has a certain sense of individual dignity that Marxism doesn't. For example, in this approach, if you prefer to buy the latest iPhone rather than pay your rent, if you prefer it, it's rational. Whereas in Marxism, it's ideology, right? So in some sense, this approach confirms that if you chose something and it was a possible deal, who is anyone to say anything against it, right? So in some sense, it rationalizes experience, right? It says it wants to be a science of the experience of having preferences and how preferences are allocated and commodities are allocated based on those demands, right?
Yeah. It's a bit like you learn your own preferences.
Yes, that's what I wanted to get. Like,
Yeah.
because like with psychoanalysis, we have this basic definition of desire that I think is very fitting, which is you don't simply desire something, you desire what you learn about desire by wanting that thing, right? So, for example, a classic thing I see all the time in the clinic, men who desire women, not because of women, but because it gives them a sense of what being a man is, right? So it's the same structure of what we were talking about. The game is not at the level of the object. The game is at the level of learning what the game is. If I want something that is very normative, very orthodox, I'm not getting as much from the thing as I'm getting in terms of knowing now what the rules are of the game I'm playing, right? So there is a sort of mapping surplus that you gain by adopting some preference, right? Or by wanting something. You learn what you want by wanting it, right? I think you explored a lot of that in the text on desire and rational choice.
Mm-hmm. Yeah, that's
right. And I mean, this is the sort of surplus you get by adopting certain assumptions, right? If you take this perspective, you're not only getting, let's say, you're not only acting within something bigger than you, but you also get as a bonus an image of that thing bigger than you in which you fit, right? You can treat it as a description or a prescription, but either way, it's a sort of feedback of your actions onto the actor, right? Whereas in Marxism, there is no rational, no legitimate feedback. This feedback is called ideology, right? Oh, you act economically, but everything you learn by doing this is actually mystifying the reality, because scientifically, for Marxists, the social reality is removed from that experience. So anything that gives that experience the sense of authenticity is actually mystification. It's not necessarily wrong, but I think this speaks a lot to the lessons to learn from this, because if you want to propose a prescriptive approach to economy, right, that is politicized, that's kind of the thing you need to tap into. For example, people would like to buy from cooperatives also because of what that says about them as actors, right? Like, you get a map of the world together with the thing you bought, which I think is something that in microeconomics it's not explicit, but it's there. You know, whereas with Marxist theory, it's not.
Yeah, in a sense, it seems like you're saying that even if in, I don't know, pure Marxist theory, there's no rational feedback, even ideologically speaking, that there might be certain rational courses of action taking the ideological element into account, like a meta-rational kind of action, even if you're in ideology, in a sense. Like, it is rational to seek such and such and such things in a certain sense, right? Like, it seems like these can coincide without really overlapping. Like they won't overlap regarding their criteria, but they can coincide in a sense. Like, the same act can be ideological, but can be rational because it's taking into account a certain ideological element as it should be, like in an individual sense.
I think this is a good point, because what should not be left out of consideration is that, let's say, all rationalizations about economic life are ideology. But if I know the other is mistaken in the same way as I am, I can then make a new, truly rational assessment, right?
Yeah, you take into account the fact that this has traction.
So,
and this to take that into account is rational. So yeah.
Yeah, that's what I think that in microeconomics is nicely connected. You know, like I think it connects with what Yasha said about scaling. I mean, I know we're kind of drifting away from the topic, though I think that the open games thing fits this nicely. But it seems like microeconomics is more, is for some reason, even perhaps because it starts from individuals or whatever, but ultimately it is more ready to account for those meta-rational stuff. Like, it doesn't matter if it's true. It organizes the costs, therefore it's true. It goes back to what we were talking about.
Exactly. Right? Like, it's not literally true, but it need not be literally true.
Exactly. It carries together economy of belief, right?
Exactly, and it's true in that sense. Like, this will make this economy of belief visible. So you can have true propositions about the economy of belief and about how to engage in a world wherein people are engaging also in that way.
Yeah, I think I understand what you guys are saying now, because that is a very Badiouian motif, right?
Yeah, this is actually where I wanted to get at, you know, because ultimately, I mean, the thing that Zizek studied that Badiou never studied, but we had a lot of conversations about this, is that Zizek is always about belief, and Badiou is about fidelity. So it's like faith versus belief, right? Faith is something you assume in the first person. Belief is something that works even if you don't assume in the first person. Like money is really the paper it's printed on. Everyone knows it's not, but we believe that someone else believes. So I get the money. Let's say it's a counterfeit, but it's a perfect counterfeit. So perfect that I know that somebody after me will guarantee accept it. I will accept it.
Mm-hmm.
Right? We see this in, I love this. This is one of my favorite phenomena. Like you have a paper money and it's torn. There is a certain specific limit point that the note can be kind of torn and you will accept. And if it crosses that limit, you won't accept. But that limit is not defined based on your beliefs. It's defined based on the beliefs of the person who will receive it from you later. If
Yeah, it doesn't have that co-utility. Like,
yes, that's where, isn't that the co-utility thing?
Yeah.
So
it's a great example. Yeah.
Right. I mean, so it clarifies that the knowing what the game is and playing the game are intrinsically connected. And the name that we call this is the economy of belief. Right? Belief is a more abstract version of the practical description of knowing which game you're playing with others. Because if I know the other is playing such a game, for example, of accepting a very torn piece of $1, I can accept the $1 because it will, that's the game we're playing. It's okay. Whereas if that's a bit too much, then I cannot accept it. Even though for me, I don't have an exact preference on that. The preference that it's actually coming from, knowing the rules.
Right. So the rule is something that is constructed from the outside, in a way. Like it's.
Yeah, and I think it's not only constructed, but it is, let's say, part of the thing at stake, right? It is part of the game that you learn about the rules of the game as you play, like that they get confirmed or disconfirmed, that beliefs are confirmed or beliefs are not confirmed. That's, I think, part of economic crisis, right? You might need things or you might not need things, but that dimension is kept, but suddenly you don't know anymore if the game is valid or not, right? So you still prefer to have money at home than to store goods, because money is functionally better than goods. It can be exchanged for any goods, but you're not sure anymore if people will accept your money because of inflation. So it's not only the distribution of goods which is affected, but the certainty of the rules of the game being played. You might have
just to bring this back to this formalism here. I mean, can we say that all of these conditions that allow us to formalize kind of a geometric intuition for preferences and to calculate optimal allocations and so on, that's all assuming a certain coherence to the game, right? Yeah. Something like it's some additional parameter, not in the game itself, but rather in the
it's all, I mean, I don't think that this works, okay? But it's almost as if the fact that this continuous line here partitions this into two, it defines that this is a player 1 and this is a player 2, right?
Mm-hmm.
So you get it's almost like saying when you find a point of exchange, you're also defining what it means to be a player on both sides, right? So the rule is also being confirmed by the fact that you can exchange.
Yeah, I like that. It's actually going from the exchange back to the preferences. Like the indifference curves can be kind of generated from the exchange if you just assume that every exchange is a confirmation of
Yeah, it's
of
all
optimality.
exactly that. Like the curve define. I mean, you can just invert the order, right? If we exchange, then that was your preference, right? Then we agree. Not that if we agree, then we exchange. And I think that's kind of how the logic goes. Like if the guy took this job for less than a minimum wage, then it's his preference.
Yeah.
So that's the sort of input that you're getting for free, right? The sense that this is the true game because being played, because after all, the exchange did happen. And I think that this explains why perhaps, I mean, you can actually map this structure on top of a more objective approach to political economy, right? Because it's almost like there's a generator, a local generator of the economic gain by the very fact of exchange happening, right?
Mm-hmm.
The more exchange is happening, the more it is confirmed to the actors that they are actually playing the same game. Even though if you look at, let's say, the quantities of conditions of labor or laborers in the labor market and what people are actually willing to accept wage-wise, you can see the worse their conditions, the more they're willing to accept worse jobs. Okay, that's something you need to remove yourself from your perspective and take labor as the measuring stick. But if you're not interested in mapping social reality, and you just take the fact of the exchanges having happened, social contracts were established, you could just overlay on top of that this sort of curves, and they would generate, right, equal players, right?
Yeah.
Like a redescription in terms of where we stand, right, with regards to economy.
I think, it reminds me a lot about what we're trying to do with like the exchangeability thing, right? Like green here is kind of like maximum exchangeability. And as you deviate from maximum exchangeability, you can kind of produce these curves.
Mm-hmm.
I don't know. There's something like that there. Yeah.
Yeah, there's something.
But the move from objective to subjective seems very
because
much more.
Yeah, because
promising.
like we suddenly, if we just take that idea into the picture, I mean, and I think it connects with what Yasha was talking about, scale relativity, because it is kind of a confirmation of the right resolution, right? That individuals are the right resolution to assess the meaning of exchanges. But once you have this hidden variable explicit, that when you exchange, you're both, let's say, to find optimal point is both to exchange two things and to confirm that that's the game that's being played, right? You get the commodity and you get, let's say, the manual for what it means to behave economically, right?
Mm-hmm.
Both things. Suddenly, you actually made the objective theory of the subjective, right? What was previously called the subjective is actually the let's say the result of that process and not the origin of it, right?
Yeah, but I mean that falls very much in line with the general idea of fetishism. Like fetishism is a type of rationality, I think.
Yeah.
It's
yeah, but
it lets you see certain things.
Yeah, but I think it becomes also something. I mean, we would call it fetishism because of the information it loses, not because of the operation in itself.
Mm-hmm.
Which then requires us to ask the same questions of any other economical form, right? Sure, it can be described theoretically, but you still need to account for what it means for the man on the go, right? So you need the objective description of what we call subjective. point of view.
Mhm.
Like what would be the discussion of optimality of, you know, a game theoretic approach to an economy that is organized under different principles than you know, that then can directly be assessed by the goods you got, right?
Yeah. Yeah, it's very interesting. I think we should end soon. I think the other points here we could cover at a different time.
If you want to just like quickly hover through them, just so we can get a.
Yeah. Okay. Yeah, let's just try to go quick. So, extending this notion of the contract curve, we can talk about this market core, right? A higher dimensional surface that kind of connects all the indifference curves of all the participants, right? Not only two people and two commodities, but n participants and n commodities. So we can create this notion of a competitive equilibrium, right? Competitive equilibrium is an equilibrium allocation, so exactly a point that lies on this curve, plus a price map, such that no trader could buy and sell his way into a more preferable set of commodities. So, like, let's say we're at equilibrium. If the prices are such that I cannot sell some of my commodities to buy the commodities I would rather have, then this is a competitive equilibrium, right? Because imagine I own some commodities and I have a certain utility. Now I think like, oh, well, if I sell some of commodity A and I buy, using that money, I buy more of commodity B, I'll actually be happier, right? If I could do that. A competitive equilibrium means you cannot do that because the prices are such that I cannot buy enough of commodity B to offset the losses of commodity A, right? The loss of utility from selling commodity A. Okay. And then this famous economist, Allman, showed that in a continuous market, so a market with infinite traders, the set of core allocations is the same as the set of competitive equilibria. So this is kind of going in line with what Yasha said and what we've been talking about, that you kind of need this unrealistic situation to happen to model the competitive equilibria, right? You need an infinite number of traders to kind of create that surface, to create a smooth surface.
The core allocations are these like surfaces where everything is equalized, right?
Yeah, the core is this green. It's an extension of this to n dimensions.
I see.
Yeah.
Is that where you got the idea for the core of the commodity thing when in our definition of the exchange function?
Yeah, the word, but I don't know if the idea is
no, but there is something to it, like finding we were trying to find the quantities at which commodities are exchanged maximally. I mean, it does seem like it a bit.
I think we could stretch it to be because in some sense, like you could say if this green line were maximum probability, like this is, once you're there, it's like no one wants to deviate from it. Then moving away from the green line is like deviating from some maximum probability. Like the green line is most likely to happen, I think.
Would you say the competitive equilibrium is a sheaf also? Because it's like global consistency of all of the, I guess like, payoff functions.
Yes, that's actually the question I wanted to ask with the last 4 slides. Yeah. So defining what a sheaf is, right? Remember that we can glue, we assign to some open sets some data. It doesn't matter what it is, but usually it's like sets of information. And if they agree on some overlap, which is the bottom right of this square diagram, we can do a pullback. So we can glue them together, right? And this whole thing will commute, right? So that given that basic definition, and this is another version of the same thing, this is exactly the same as this pullback diagram. I propose this to end the presentation, which is let E and P be open games called exchange and production. And within each game, can be sub games, right? So these are just the envelope or the largest game accompanying all these other games. And the context of each agent in each game is determined by some valorization process. So, the goal of the game is to make as much money as possible, right? To valorize. Let X be a space of markets comprised of such pairs of games. Then a pre-sheaf of prices assigns to every game a competitive equilibria of commodities to its players, and a pricing map such that restrictions of the pre-sheaf correspond to inclusions of games. So like if a smaller game is included in a larger game, then there should be a restriction of the pricing map to that smaller game.
I think a good example of the restriction could be like a family structure, right? Where there's like breadwinners and they pay for things for their children.
Mm-hmm. Yeah, you mean like you're restricting from the breadwinner to the children?
I'm even saying restriction from the game of like the broader economy to the game of like maybe an individual family, right? You can like do this little like change of scale with this I think this is exactly the right idea.
Yeah, exactly. So you assign some, so you have the economy as such, global economy, and you can restrict that to as far as you want, like to the point of a single family, if you want. And that would be
got some music playing?
Oh, do you hear music?
I don't
Is
hear
that
it.
you, Dennis?
No, I don't.
Oh,
I don't
hold
hear
up. That
anything.
might be 1 second. That might be some. Oh, I know what it is. Something open in the background of my phone.
Oh, okay.
They're very high tech nowadays. They can do multiple things at once.
Yeah, I thought maybe I couldn't hear. Something wrong with my ears. Yeah. So anyway, given all this crazy stuff, trying to combine everything from the previous slides, right? Does there exist a non-empty sheaf of prices? So is it possible to formalize exactly what you asked? Like, is there such a thing as a sheaf that could maintain competitive equilibria from local to global?
I mean, Hayek would say yes, and he'd say it's one that's just kind of free for all.
Yeah.
Free for all capitalism.
Yeah, I think we made some progress in this by what we were just discussing about how microeconomics assumes that whatever happens is the equilibria for individuals. So like, let's say you have some global equilibria and you restrict down to the individual. Microeconomics almost says like, well, even if that individual took a job below minimum wage because of larger economic forces, the fact that they accepted that means that they confirmed their preference structure. Like it somehow like maximized their utility given their options.
Yeah, it doesn't. I would say like it doesn't take into account the structure, like the choice structure of each individual, but also almost maybe more importantly, the common preferences to everyone, like this like intersection of preferences, right? Because like everyone wants food and like to be able to have healthcare and whatnot. And I think that's also something that microeconomics misses.
Yeah, exactly. Because microeconomics would say if you don't have healthcare, it means you didn't want it enough.
Yeah.
Right. You didn't want it as much as other things that you have.
It's interesting.
Yeah.
Dude, I just realized this. So ultimately, microeconomics is a theory of the distribution of mappings of capitalism.
Yes, it's
right. I mean, if it actually inverts the order and it says, if you accepted and then this is what you wanted, it's actually distributing let's say, a very uneven theory of desire everywhere. It's not really departing from it, it's actually giving you that, right?
Yeah. Yeah, we could say that the rational actor is a restriction map of the valorization functor.
That's cool. That's really cool.
Yeah.
Yeah, I like that.
Yeah, like if there's such a thing as like global capitalist rationality, then the individual rational actor is like a piece of that. But the fact that it's a sheaf doesn't mean it's, I mean, it actually implies something bad, right? It doesn't mean it's like consistent so much as it means what the rational actor has to make it consistent.
Yeah,
at
it's
the
all
individual level.
it's almost like the Nash equilibrium in that way, right? Where it's like each person given their choices that they can make given the rest of the world, like are they benefiting the most they can, which like might not be very much.
Mm-hmm. Yeah, and the goal or the outcome is that you actually have to want to uphold that rationality.
Mm-hmm.
Something like that. Yeah, there's some connection between individual desire and this objective function that I think what we touched on.
Mm-hmm. Man, but this is really, really interesting. I mean, and it is a clear development of something you were working on a while back, right?
Yeah, this
Yes.
is good.
Yeah. I mean, I'm really interested in this. I think there's more stuff that we could get from microeconomics, but we need to keep in mind this this reversal.
I think that if we understand exactly what it is a theory of, right, in this sense that we're talking about,
Yeah.
it makes it easier also to, I mean, given the effectivity and the importance of it, to take seriously that whatever it is a theory of, we need to have a theory of that.
Yeah, I see what you mean. What does it refer to?
Yeah,
when it
I
talks
mean,
about this preferences.
Yeah, if preferences are they have this weird feedback about them, right? In some
Mhm.
sense, you also prefer to find out what your preference is, or you part of your preferences is to know the game you're playing. And well, if this is relevant, or whatever version of this is relevant, and what Hayek called price information actually is also information about that, right? It's not simply information taking you into the social reality, but it's also information about your place in social reality, right? Well, that opens up a question that needs an answer, even if it's not, just let prices run amok. Okay, but it remains a problem that will have to have some other solution, right?
Yeah. Yeah, because then you could say that there's actually several solutions, so there can be more than one solution to this.
Exactly. For example, you can have, I mean, politics usually has this aspect, right? I mean, make the politicization of economy is a bit like that. It says in the most vulgar versions, which I think are not sustainable in the long run, but it suggests that you should buy from these people, or you should invest in this because of what it means or who they are or whatever, right? So it's building into the game of some process, something that is not your individual preference, but it's something you gain from it. Like the more you invest in this, let's say, organic stuff, you also get the knowledge that you're helping the world, right? That idea, which is for good reasons taken to be quite problematic many times with commodities and so on, the way they build into themselves this sort of, surplus enjoyment. I'm not only buying this, but I'm also kind of already paying my dues to the environment or to politics by buying from Mexican coffee farmers rather than rich, you know, that sort of thing, the sort of Starbucks mentality. It's not interest. I mean, it's clear that this is then added to the price and so on and so forth, and surplus can be extracted. But the fact that prices are a mechanism that can absorb this sort of information, right? Tells us something about the immediate role that prices play and the capacity of prices to actually not only carry information across different scales, but also carry scales through information, right? I don't have access to those things, but like I can see myself connected with those things. There's things like this. I think that this is something that is more easily seen in what you're showing than in Marx's description of, you know, object produced by labor, and well, this problem is not even posed, you know.
Yeah, maybe we can say that the best response function is kind of like a scale that's carried over through games.
Yeah,
in the sense that you it's not just about you, right? Your best response is the best response of anyone given what you've observed.
Mm-hmm.
So it's kind of like a, you know, it could include everyone in the world. You know, the strategy profile can be very large. So
yeah,
there's that. You know.
Yeah, it's something I'm not sure yet how to formulate what I'm thinking, but yeah, it's something that seems to go in that direction.
Mm-hmm.
Yeah, man, but this is really interesting, especially this last bit.
Yeah, I enjoyed this a lot.
Thank you. Yeah, I'll definitely send out some links. I have a bunch of some Wikipedia stuff, but it's also some interesting articles that go more in depth on all these topics.
Yeah, send the slides too. Also, I feel like we should, on the website, the slides would be good to have there, just like as a file.
Yeah, I think it's easy to upload now.
This is a good reference. It should be pretty easy to do.
Yeah, now it's easy to upload on the pages for each presentation. There's a space where it's easy to add stuff.
Yeah,
okay.
I can also make it so that the attachments show up on the homepage, but I don't know if that would clutter it too much.
Yeah, I think it's okay
probably
if
just
they show
when you click each one, but
yeah.
Okay, when you click into each one, yeah, then that should already be possible.
Yeah, I'll start adding for my old presentations.
Yeah, okay, perfect.
Great, guys. I need to cook.
All right, enjoy. Thanks for this.
Take care.
See you guys.
Thank you. Bye, guys.
Bye-bye.